Welcome to our channel Edu9. Today in this video we are going to discuss about the topic of relatively prime or prime to each other integers. What is relatively prime numbers? Suppose we consider two integers a and b, then both not zero, then these two integers a and b are said to be prime to each other or relatively prime if their GCD is 1. That means if we consider two integers, for example 2 and 3, 2 and 3 itself prime number, so their GCD is obviously 1, so we can say that 2 and 3 are prime to each other. But it is not necessary for the concept of relatively prime or prime to each other that the integers a and b are always prime. They itself may not be prime. Suppose we consider two integers, one is 6 and another is 49. Here 6 and 49 both are composite number, but 6 and 49 don't have any common divisor except 1. Therefore, their GCD will be 1. Therefore, these two numbers 6 and 49 are said to be prime to each other or relatively prime. That is, if between any two integers we can find out the GCD as 1, then we must say that these two integers are relatively prime or prime to each other. Now, we will go through some important statements or results on the concept of prime to each other numbers. Suppose two integers a and b are given which are prime to each other. Then we can find, then there must be two integers u and v such that au plus bv equal to 1. How is it possible? Because we know that GCD of any two integers can be expressed as au plus bv where u and v are some integers. Here the GCD of a and b will be 1 because they are prime to each other, and we know that the prime to each other integers must have GCD as 1 from the definition. Therefore, au plus bv equal to 1. Therefore, if we ask the statement as a and b are prime to each other, then it will return au plus bv equal to 1. Again, if we are given that au plus bv equal to 1, then we must conclude that a and b are prime to each other integers. Our second statement is if d is the GCD of a and b, then if we divide the integers a by d and b by d, then the new integers a by d and b by d will be relatively prime or prime to each other. That is, their GCD will be 1 because the greatest common divisor are removed due to the division. So their GCD will be 1. Again, if a divides bc and GCD of ab equal to 1, that means a and b, these two are prime to each other. Therefore, a divides c. Why? Because a divides bc, that is, a divides this product. Thus, there will be a factor of a between this product bc, but we are given that GCD of ab equal to 1, that is, a and b are prime to each other. Therefore, b does not contain any factor of a. Therefore, it is clear from that c must contain the factor a. Therefore, c is divisible by a. Hence, a divides c. Next statement is if a divides c, b divides c, and GCD of ab equal to 1. That means a divides c and b divides c. A and b are prime to each other. So simply an integer c is divisible by two prime to each other numbers or integers a and b, which implies ab divides c. That is, if we multiply the prime to each other numbers ab, then AB also divides the integer C, which were individually divisible by A and B. Again, if we are given two prime to each other integers, that is GCD of AB equal to 1, again GCD of AC equal to 1, then from that we can conclude that GCD of A comma BC equal to 1, that means A and BC are prime to each other numbers.